A Taylor series is a power series. It just gives us a unique way for finding the coefficients. We saw that it was related to successive derivatives of the original function, and given that we know what the center is, we can come up with a polynomial to approximate any function that we would like. So we're going to do another example similar to the strategy that we used in the previous example. Here, our function is square root of 1 plus 2x, and the center is going to be at x equals 0. We want to find a fourth degree polynomial, which means that we'll need up to the fourth derivative here. So let's write our function as 1 plus 2x to the 1/2 power, knowing that we're going to have to take derivatives. So the first derivative is 1/2 1 plus 2x to the negative 1/2. We just want to make sure that we also multiply by the derivative of the baby function, which in this case is 2. If you want to, and you know that you're going to have to take successive derivatives here, you can reduce the 2 and the 2 to make it a little bit easier for your derivatives from here. So our second derivative would be equal to negative 1/2, 1 plus 2x to the negative 3/2, and then times 2 again, because we're taking the derivative of the baby function inside. This itself reduces to negative 1 plus 2x to the negative 3/2 power. And so the third derivative here is a negative times a negative is positive, so positive 3/2, 1 plus 2x to the negative 5/2 times a 2. So again, reduce, we get 3, 1 plus 2x to the negative 5/2. And then lastly, since we want fourth degree, we're going to go up to the fourth derivative and the fourth power. Take the derivative, we get negative 15/2, 1 plus 2x to the negative 7/2, and then times chain rule by 2, which reduces then to negative 15, 1 plus 2x to the negative 7/2 power. So after this, what we do is evaluate all of it at x equals 0 at the center. So plug 0 into each one of those. So for my first one, f of 0, I'm going to plug this 0 into here and get 1. So I'll just do 1 here. On the next one, if I plug 0 in, I still get 1. If I plug 1 into the next one, I get negative 1. Into the next one, I get 3. Into the next one, I get negative 15. Now that's going to jumpstart all of my coefficients here. So if I want a fourth degree polynomial, this is one way of naming it. You can see the 4 in the subscript for p, which stands for polynomial. And we're going to take the fourth derivative, which in this case is negative 15 evaluated at 0 is negative 15. So we'll have negative 15 over 4 factorial x to the 4th power. And then continue on, we have positive 3 over 3 factorial x to the 3rd power, and then plus minus, in this case, minus 1. And I think it might be easier, I'm switching colors here. Minus 1 is going to be from my second derivative, so it's going to be over 2 factorial x squared. The next one would be your 1 here, which is your first derivative over 1 factorial x to the 1st power. And finally, you end with your constant. Technically, that is over 0 factorial, which is 1, and then to the 0 power is also just 1. So we have that plus 1 at the tail end. And so that is our fourth degree polynomial. Expanded out, if we wanted to, we can also simplify the factorial. Negative 15 over 24, x to the 4th, plus 3 over 6, x cubed, minus 1/2 x squared, plus a 1 x, and then plus 1. if we wanted to, we can also reduce all those fractional values. So over here, I'm going to write out my answer in reduced form where it says p sub 4 of x. So negative 5, 6 x to the fourth plus 1/2 x cubed minus 1/2 x squared plus x plus 1.